Okay, good morning, good afternoon, good evening, everyone. My name is Eric Bush. I'm the CEO and co-founder of Demand Driven Technologies, and delighted to be your host today for our second webinar in the Agility and Resilience series. With me is Wally Leisure, our Director of Solution Consulting, and Brittany Rodriguez, one of our account execs, who are going to be joining me as panelists on the discussion today. From an agenda standpoint, we're going to go through a presentation and a set of demos to help illustrate some of these concepts. But before we do that, I want to just talk a little bit of housekeeping for the webinar. Everyone will be in listen-only mode. That's to help keep the audio quality good for everyone in the web conference. And that does not, though, mean that we are not interested in your questions. You'll see a question panel on the Zoom control, and you can utilize that to ask questions during the session. We'll cover those off at the end of the session to make sure that we address any questions that you may have. We are recording the webinar, and so you'll be able to get access to a link of the recording for utilization for your own purposes or to refer over to other contacts in your organization if so desired. And then finally, we're obviously keen to take this story forward. So any thoughts or feedback or suggestions you have around the webinar itself, content that we're sharing, the ideas that we're sharing, we're all ears to hear that and learn from that. We think this is a very important topic in today's supply chain environment and want to really do the best we can to help you and our other clients make progress going forward. I'm going to take a few minutes to go back to what we discussed in the first webinar in this series around the market realities and why there's so much talk about the need for agility and resilience. And then what we're going to do is take that context and bring it down and look at it in the context of the material planning activities within a supply chain. How do we bring agility and resilience to that dimension? In future webinars, we're going to be covering how we do that for sales and operations planning, production scheduling, and execution. And so we're going to kind of take it a step at a time here, helping you create the foundation for that sought after agility and resilience so that you can improve your supply chain performance. We're going to talk about some of those tactics and techniques. Obviously, we'll do some demonstrations within our Intuiflow software to hopefully help illustrate how you bring those to life. And then we'll wrap up with some summary thoughts as well as handling any questions that you may have along the way. In terms of the realities here, I'm missing a chart, but that's okay. In the last session, I showed a chart that illustrated that U.S. manufacturers' inventory turnover rates had not progressed in the last 25 years. This is according to data from the U.S. Federal Reserve. And it's quite remarkable in the context that from the period of the mid to late 90s that till today, that we have been kind of plateaued in terms of inventory turnover rate performance. And I think that's a bit of an indictment, frankly, of the wider software industry, because you would have thought, given the massive deployments of ERP systems, other software solutions in the supply chain space, that we should have gotten to some improved or sustainable level in terms of inventory turnover rates. And the reality is that we're still fighting a lot of the gremlins that have been out there for decades. Inaccurate forecasts probably top the list. Today's planning systems are heavily dependent on accurate forecasts, and the reality is that they're not really improving. A lot of that's due to product proliferation and SKU proliferation. A lot of it's also due to more competition and other challenges in the market. We also see clients are struggling with issues with staffing and labor issues, both at the plant operational level as well as in the supply chain planning community. We've got more items to manage, and yet we're having to do so with less people, and oftentimes people who have less industry experience or supply chain experience, given turnover rates that we're seeing in some of our larger clients and their workforce. That puts people in this perpetual firefighting mode. The item proliferation is not helping us, and so there's all these workarounds and other tactics. And all of this kind of storyline leads us to the reason why is it this way? You know, how come we're finding ourselves, after all this modernization we tried to do with our software solutions and the like, that we're still kind of stuck in kind of these challenging conditions? If you look at it, the core concept that's the most pervasively used across supply chain planning is the concepts based around material requirements planning, or MRP. And it's a very, very logical thought, that if we can feed it our forecast, it will backward schedule the things we need to buy, then manufacture or assemble, package and distribute to meet that forecasted demand, right? It seems so straightforward. But obviously there's some critical assumptions underlying that logic that we ought to take a look at and see if they're really relevant in today's situation. First is that the demand is known, that our forecast is accurate. And obviously we know that, especially when we take it down to the item level, that forecast accuracy is typically at best in the 50 to 60% range. Maybe when you take it up to a category or regional level or something like that, you can get into the mid 80s to low 90% range, but that's not what consumers are buying. They're buying the item itself. And so forecast accuracy continues to plague us. And it's the foundational assumption that we have in our MRP environment that it will be accurate. The other key assumption out there is that there's not going to be any variation. And we all know that that's absolutely not going to be the case. We're going to have issues in our logistics networks. We're going to have issues with suppliers who have problems. We're going to have issues with market demand variation and the like. We have to build in more flexibility to deal with that variation. Clearly, the other assumption is that item master data is accurate. Whether you're using MRP or any other logic, you do have a responsibility to make sure your item data is clean so that you can get better value from the solution. So the question I would ask is, can we rely on our traditional methods to create true agility and resilience? Because those seem to have a little bit different characteristic than what we're used to in conventional planning. Went to the dictionary, looked up the definitions of agile and resilient. Agile is marked by the ready ability to move with quick and easy grace. Think of anything that comes your way. You're able to pivot, respond, be very graceful in doing that. Those would be kind of great ways if we could describe our supply chains in that fashion. And resilience is defined as the ability to withstand and recover from difficult conditions. And if we really are intent on achieving these kind of dimensions in our supply chain, we have to make this statement at the bottom come true. We have to become more comfortable with the idea that the only certainty we know is that we will have an uncertain future. The more we embrace that philosophy, the more I think we're going to look at our supply chains and turn our attention in a different way to get to better results, right? Become comfortable with the idea that the only thing we can be sure of is that our future is uncertain. And by planning and building supply chain resilience into our model, we're going to be in a better place. So we want to shift this concept then and take a look at how do we apply this idea in a material planning environment. And every company has their own position on this spectrum. On the left side, we're talking about being in a make to order environment. And if you're heavily make to order, right, essentially everything you do is custom and specific to that customer's request. There may be almost no common or shared materials in it. So at the far end of that, we would typically think from a material planning standpoint that we are not holding stock. Everything is what we would call non-buffer. And so you can see a high percentage of the items here in the low demand pulse counts are going to be not buffered because they're going to be bespoke to the specific order that we get from the customer. On the right side are items that are heavy runners. They're steady runners. We can be very much in a make to stock orientation. We may be using concepts like DDMRP buffers to handle that. We may be using some min-max philosophies and the like. And every company is going to fall somewhere between these two ends of the spectrum, either heavy make to order, heavy make to stock. And so the question becomes, if I want to become more agile and resilient, then how do I do that, given every company's unique paradigm is going to be specific to their own environment. And obviously, it can't always be either make to stock buffering or whatever we're going to do on the make to order side. So the idea here with this chart is to try to capture what are some of the tactics that would allow us to become more agile and resilient. Well, let's start with the easier side of this story, which I think is those that are in more of a make to stock environment. If we can hold constant availability of our end items, then logically we should be able to ship the same day or within 24 hours any order that actually comes in. And so the idea of buffering is that we're going to establish a stock position and we're going to manage it in such a way that it ensures its constant availability. Once I achieve that, now I'm ready to ship when the order comes in. Think of Amazon, you can order and you'll get it the next day, sometimes even the same day, right? And so there's some tactics in doing that. Buffering is one of them. We're going to talk a little bit about that today, but it's to be applied where appropriate, not universally. And that's a key part of the DDMRP method is let's use that technique strategically where it can gain us advantage. The idea of constant availability allows us to decouple lead times and compress our response time to the market. And this is also going to have application in the make to order side, and we'll talk about that in a minute. But the whole idea of constant availability is a very foundational idea that the better we are able to protect that, the more it opens up other doors and avenues through which we can become more agile and resilient. And then from a production scheduling, even if I'm in a make to stock orientation, I have to use my production capacity wisely. I want to prioritize my make to stock orders based on the penetration of those buffers and the like, and use my production resources in a way that's as responsive to the market as we can make it. If we can achieve these kind of characteristics, I think everyone would agree we're becoming more agile. Now, on the make to order side, you've kind of got a spectrum within this. If I have no common components, I'm on the left side of this environment, then I'm truly in a job shop, make to order environment. I may be a huge job shop that's doing custom systems for the energy or, oil and gas or other unique environments. In those arenas, your ability to become more agile is going to be about how well you are using your production capacity. And when we do the scheduling and execution session in this webinar series, we're going to talk about leveraging concepts like time and capacity buffers that enable us to manage variation within the production environment and improve our due date performance. And so I would encourage you, if you're in that kind of end of the spectrum here, to make sure you put that one on your calendar, which I think is in 4 weeks from today. If we're on the other side of this question, that there are common components, maybe we're more assembled to order or configured to order, we had the opportunity to compress our lead time to the market via decoupling by buffering some of those shared components, ensuring that they're always available. That also helps us improve our promise date performance because we can use execution priorities and other techniques to drive that story in a better way. So wherever you are on the spectrum that we've talked about here, either from a make to order standpoint or make to stock, there are relevant aspects of this from a material planning standpoint that you can consider. If you're purely make to order, then it's all about production scheduling and how you utilize that capacity in a wise way. We have a webinar coming up just for that kind of story. Okay. So from a material planning, how can we become more agile? If we can pace to true demand, it's the most accurate signal. It takes away the exposures we gain when we try to do things to the forecast. It is by definition agile because you are waiting until the order comes in to respond, right? And the buffering we'll talk about enables you to do that with high reliability, very, very high service levels, which also then has this second benefit of compressing lead time. And we'll illustrate this in the demonstration coming up here shortly. The other concept that's so important in buffering is that it manages variation. It gives you the ability to really insulate yourself from both supply and demand variation in a manner that allows you to protect that constant availability, decoupling within your supply chain and giving you that responsiveness to the market. So a big piece of this, where appropriate, is utilizing DDMRP buffers as part of the story. What does that really mean? So a DDMRP buffer has basically 3 zones in it that are of relevance. The first is the yellow zone, which is the amount of supply we need to cover our replenishment lead time. So the usage over the lead time is the amount of stock we would need to cover that lead time. If we have a 10-day lead time and we're consuming 100 per day, we would have 1,000 units in our yellow zone. We order at top of yellow. the material should arrive at bottom of yellow and everything should be great. Now, we know that's not always going to happen. So we need to protect ourselves for variation. The usage could come in heavier than that 100 per day. The lead time may not be achieved. It could come in late. So the red zones are there to address variation. And I think this is where companies should focus, not so much on forecast, but on understanding what are the causes of variation and how do they best to deal with that. Wally's going to show you how the AI/ML technology that we've developed can help ensure that the red zone coverage you're building is adequate to meet the types of variation patterns you experience. Because items with the same coefficient of variation don't always need the same level of red zone coverage. And then the final element of a DDMRP buffer zone is the green zone. It's what we order on average, typically a minimum order quantity or something based on an order frequency. If we want to order once per week, once per month, the green zone will reflect that. By doing that, we achieve this idea of constant availability that is so strategic to our quest to become more agile. And the key to that is all about managing variation in a more effective manner. So with that, I'm going to hand it over to Brittany, who's going to first take you through some illustrations of Intuiflow and how we help bring agility to life. Brittany?
Great, thanks, Eric. So I've logged into Intuiflow, as you can see on the screen, and right now I'm in my materials planning workbench. So you can see I have all of my parts that are sorted by priority. And when I look at this inventory method, replenished, these are the parts that Eric was just referring to that have a buffer applied to them. Non-buffered, these are my buy to order or make to order parts, or I have parts that are managed with a min-max. However, I'm still managing all of these parts in one view in my workbench. Let's say I want to drill down and just look at my parts that have a min-max setting applied to them. I can configure my workbench for that view. Or I'm in a completely make to order environment, so all of my parts are non-buffered. I could filter down right into that view for my workbench and concentrate on those parts. In this example today, I'm managing several different parts in my workbench. One of the things I could also do is I could plan by vendor, and I could drag this up to the top. And now I still have all of my parts that I'm planning to by vendor, still sorted by criticality. So a lot of different ways to configure my views and save time in my day for how I want to plan. So first, I'm going to take a look at a part that has a buffer applied to it. This is PPJ. And I'm going to this analytics tab. And what I'm looking at here is how my parts, or how this buffer has responded to demand over the last 6 months. What I see when I'm first looking at this is that at the beginning of the year, my buffer was a lot thicker. The demand for this part began to fall off. The buffer is picking up on these changes as they are happening. It's realizing that the demand is falling off, so the buffer shrank in size. I didn't have to manually adjust anything. The buffer is resilient to what is actually happening to this part in the market. If I were to see the demand for a part begin to grow, I would see my buffer thicken in size and tell me that I need to order or make more because the demand is growing. This is all happening automatically. I'm not having to manually adjust anything. And like Eric said, this buffer is taking into account my MOQ. It is taking into account daily usage, my lead time, and variation. And it's all based off of the demand that's of the time frame that I'm looking at in this example, which is the last 6 months. This is a purchase part that we just looked at. Let's take a look at a part that has a bill of material. So this is a part that has a bill of material. I'm going to look all the way through this. My finished good here, FPA, has a buffer applied to it, but I still have visibility into the components within FPA, and I see that I do have some non-buffered parts here, but I still have visibility into every component that makes up my finished good. One of the things that Eric just mentioned was, how can I be more responsive to my customers? What happens if I make the decision to apply a buffer within my bill of material? Do I compress my lead time? Am I more responsive to my clients because now I can get supply out the door, made out the door to them quicker? So in the next example, we're going to switch from this make to stock environment to a make to order environment and talk about what happens when I actually decouple and place a buffer on a part where I did not previously have a buffer applied. So I'm going to turn it over to Wally, and he's going to walk through what this make to order environment looks like.
Thanks, Brittany. Just pull up my screen here. Eric mentioned early on, in different environments, how do we become more agile and more responsive? So what I want to do is pull up a make item like Brittany was describing. Over here on my workbench, leveraging another saved view, I'm going to pull up my sample FPX, which is a simple finished good part. You can see here I've got an order recommendation for FPX, and my current commit date back is 8/24. The reason so is that we're responding to sales order demand, but because I am in a true make to order environment and buy to order environment, when I look at my bill of material, I'm calculating out a 35-day lead time. How great would it be, or what would it do to your current environment if you could be that much more responsive? What if we could turn an item in 10 days as opposed to 35 days? Does that gain you market share? Does that make you that much more agile? I'm going to go ahead and apply a buffer to PPA, and let's see what that does now to my response date. So you can see here, by simply selecting a buffer, we have tools to assist with this, which I'm going to show you in a second, where you can run different simulations. We also have our smart buffer profiler running in the background, but just for the sake of this demonstration, I'm going to go ahead and artificially assign a buffer here. And let's see what that does now for our finished good, for FPX. Give the system a second to refresh. And you can see now we've shaved 25 days off of our response. Now I do have to build my buffer for FPA, or PPA, excuse me. But imagine that, right? Now we've gone from a 35-day commitment to our customer or to fulfill that demand, and now we've dropped that down quite significantly. As Eric mentioned, we want to apply these buffers strategically. Where does this make sense? Is this meeting our business objectives? Is our customer okay waiting 35 days? So where appropriate, and we're here to help you with that, where we can apply some analytics. I want to jump now and start talking about some of that AI ML red zone technology that you may have heard about at our user conference, or that we may have spoken about personally. First thing I want to start with is in the site administration. We want to ensure that our buffers and our strategies are aligning with your business. And I'm calling out here on the right-hand side these AI ML settings. So you can see that as a user or as an organization, I can now decide, what do A items, what's a good service level for my A items? What's a good or satisfactory service level for my Bs and Cs? Are we in the environment, Eric talked about SKU proliferation that we see everywhere. Are we okay with C items being at a 75% service level because this person only orders them once a year and they're happy to wait for them? Service parts, things like that. So we want to ensure that there's an alignment there, and you are able to set those settings in your own environment. One other thing I want to call out is this red zone safety percentage. This is creating a floor. So in the event you wanted to drive your red zone down to 0, we can do that. Or if we want to have some safety there, just in case. Within the sales and operations planning of my menu, sales and operations planning portion of my menu, we have our part simulation. I've got that pulled up here currently, and I've got a particular part, 150138. And what I'm going to do is go ahead and run a simulation and refresh it using demand histories. And what I want to call out is this projected service level, my average inventory value in units and in dollars. And what we're seeing here is, based on the history, based on the buffer settings that I have currently in the system, I'm projected at any given time to be holding approximately $10.9 million on hand. Let's see what this AI/ML engine is suggesting and see if we can see any improvement. If I engage the ML red zone settings, I also do have the opportunity here to look at those percentages that we talked about if I wanted to maybe play with some of that. You can also do things like lead time scenarios. If I had an MOQ that was shifting, if I had some other stuff that was changing, and let's see what the impact would be. But now with my ML red zone on, we were able to get down to approximately 8.6 million with satisfying the demand that we've seen in the past. So pretty powerful stuff. You can see number of orders generated and make decisions from here. If I was happy with these settings, something else that's pretty neat is I can go ahead and save these part settings, and those will automatically update. So once I find what I'm happy with and my service levels are aligning to my objectives, I can simply save those. We want to ensure that we're gaining confidence in the settings. One other thing I want to talk about, because we've been talking about bills and materials, is our Power BI reporting. We have folders of we have groups of reports that are automatically in the Intuiflow instance. And the first category I want to point out is this Bill of Materials Explorer. So very quickly here, from a visual standpoint, I can start to see inventory status, potential issues, criticality, lead time information from a large visual standpoint. So Brittany mentioned this FPA example. So here on the right-hand side, I'm looking from the top down. So you can see FPA's got some sub-assemblies. There's items that are buffered. I've got several purchase parts that look like they're in pretty dire straits, unfortunately. So from a visual standpoint, hey, I may want to go take an action here. One other report that's available here in the bill of materials grouping is this where used graph. So I'm kind of honed in here on this ICA at the plant, and it starts to tell me, hey, let's say that I'm in a supply constrained environment. Where is this item used? What additional assemblies or what other customers are going to use this? Do I need to make some decisions? Do we need to have some tiebreakers? But again, from a very quick visual standpoint, directing me on, let's go get some additional information and make some decisions. With that, I'm going to go ahead and turn it back over to Brittany, where she's going to start talking about, hey, we're in some of these scenarios. What does execution look like? What do I need to do if I have a problem?
Thanks, Wally. Okay. So far we've talked about parts that have a buffer, have a min-max, or a buy to order, make to order, what we call non-buffered, still managing all of those in our same workbench. We've talked about how we can apply buffers within a bill of material, which we call decouple. In turn, we are shortening our lead time so that we're more responsive to what's happening in the marketplace, more responsive to our clients, and getting that supply out the door faster. These buffers update on a daily basis, so they are picking up on what is happening at the item level for each of our parts, letting us concentrate on other things for the day. Now, if I can come in, I see here in my workbench, I have my on hand, I have my open supply, I have my demand, and I also have my reorder quantity. Let's say that I've come in here and I have checked on all of these if I wanted, or I could set this up to have it automatically approve these. I would click approve selected orders. Well, that's great, but things might go a little crazy in a supply chain world, I think, as we have all realized, especially over the last few years. That's really where our alerts come into play. This is also dynamic. These changes are happening almost in real time, so these priorities are updating as our environment updates. What we're seeing on this screen is all of my parts, again, no matter the setting or no matter the way that I'm managing, they're all still showing up in this alerts functionality tab. We have 3 types of alerts. So the first type of alert is a current inventory alert. I am currently stocked out of this part. I can come in here, I can click on the part, I can leave a note, I can send that out to my team to say, hey, I have checked on these parts. I know when the supply is set to arrive. Let's say tomorrow that we have received the supply for these parts, we are no longer currently stocked out. The system is going to automatically update. I'm not going to still get a notification that we are stocked out of these. The next type of alert, and you can see that I have different ways that I'm managing these parts, but I'm still getting alerts on them, is my material synchronization alert. So these are items that I am not currently stocked out, but due to the timing of supply and demand and that misalignment, I am going to stock out on this date in the future. So do I have the opportunity to call my vendor? Can I expedite supply? Could I reach out to another vendor and avoid that stock out? The last type of alert is a projected stock out. So whereas here we're saying this stock out is definitely going to occur on this date, a projected stock out is where it's not imminent, but if my usage for a part continues at its current rate, I am highly likely to stock out in the future. Again, can I get ahead of this event before it occurs? These priorities are updating in real time, so I'm not having to manually adjust. I'm not having to check on each item. I truly know that these are going to be sorted by what actually needs my attention. The one thing that we haven't discussed yet is, this is my tactical planning, but what about my strategic long-term planning? How do I utilize my forecast? That's what we're going to cover in our next webinar. So we talked about the material planning part of our operating model. Next, on our next webinar in 2 weeks on July 26th, we're going to talk about that longer range planning and utilizing the forecast through our demand planning and S&OP functionality.
Okay, thanks, Brittany. I'm going to go ahead and share my screen, and I'm just going to share a chart that we didn't have in the deck today, but we'll make sure it's part of what we send across. This was from our user conference, and it relates to some new functionality we have coming out. Wally showed you this use of the AI ML red zones, and this has been a very critical project from my standpoint to our business, because it's been many years of doing simulations for clients. Every time we engage with a new client, we want to do simulations to help them find better settings and how the application of DDMRP might help them. And along the way, we found that items with the same coefficient of variation would actually behave quite differently. And this is an illustration of this very point. This is from this new tool that we have coming out in the fall called Autopilot, but it's the feature of AI ML red zones is already available in the current production release. Each of these items has a coefficient of variation of 1.3 as measured, so that's the standard deviation of demand divided by the average demand. So you would think they would behave consistently. And yet you'll see that the red zone factor, RZF, in each of these varies from 2.27 at the top down to 0.23 at the bottom in terms of that factor. What is that? Red zone factor means of 2.27, it would mean we are putting 2.27 times the usage over the lead time into our red zone. You can see a big fat red zone here for this item, given the variation pattern that it's experiencing. Yet the same or a similar item with a COV of 1.3 might need only 0.23% of usage over the lead time. In other words, 23% of that yellow zone size would be the size of my red zone. And obviously you see some other dimensional differences here. The demand patterns are slightly different if you look at the shape of them. I'm fond of using the Shazam metaphor. Shazam is an application on your cell phone that allows you to identify a music application within a matter of seconds. You press the button, no matter what part of the song is playing. It takes an analog sound wave out of the air, matches it to a digital library, comes back with the answer, the artist, the album, all those kind of factors. And when you look at it, sound waves aren't that different than the way these demand patterns look, right? And you can see that they all look different. They have a different shape to them. And so our ML technology is recognizing the differences in these patterns, and it's also coupling it with other key elements of the item. You can see here the green zone sizes of these are varying differently, and that's in part contributing to why some need far less of a red zone and others need far more of a red zone factor. So we're really extremely excited about this, because I believe one of the challenges in supply chain planning software today is that it still requires quite a bit of expertise and knowledge, knowing how to set the settings so that you get the proper results. The proverbial safety stock settings. How do we set those up? How well do we maintain them? We think that our advancements here with our machine learning technology are going to take this a huge step forward, which is to me so critical to becoming more agile and resilient. If I know I can have confidence that the solution is going to give me better red zone settings, I can turn my attention to other matters that will require my own personal knowledge and intervention. So with that, let's go back and look at our agenda, and hopefully you may have some further questions about that, but that's a key piece of the story about becoming more agile and resilient. Brittany mentioned the S&OP part of this story, and we'll talk about this in our following webinar in a couple of weeks. Really, the goal of sales and operations planning from a supply chain plan point shouldn't, in my mind, be about consensus demand plan begets a consensus supply plan. It should be much more about what are the different scenarios we may encounter, and how do we prepare ourselves for those potential eventualities? How can we prepare ourselves more effectively for this uncertain future that we're going to arrive in, whatever that may be? And so the role that you'll see us displaying around S&OP is going to be using S&OP as a tool to test the agility and resilience of your model, build that flexibility into how you operate from a material standpoint and from a production scheduling standpoint, so that you truly gain that kind of agility and resilience that we talked about at the beginning of the webinar. Demand planning has a role in this. Maybe it's not about consensus planning. Maybe it's about seeing kind of the issues that may occur, running a set of different scenarios and evaluating what those might do to us. There's tools and techniques for achieving that I think gain you more strategic advantage than trying to get everybody on the same page with a consensus demand plan, which by the time you launch your operations against that is already starting to prove to be inadequate. And then focus on managing exceptions. The more we're able to deal with the edge cases, the more we can let the plane fly itself and get ourselves to a much better position. Agility and resilience is about being adaptable, quickly being able to flex with market changes that come, having the ability to respond rapidly and flexibly to the customer needs that come along the way. The more you're seen as somebody who can turn around on a dime, the more your business is going to grow and compete in today's environment. The more you're able to recover from disruptions when they do occur, if they do occur. Gaining that capability strategically within your business is going to put you on a much better footing. And if you're in the supply chain planning community, put you in a much more manageable workload kind of an environment. A lot of what we're trying to show you in the demo today, and you'll see more when we go through S&OP and scheduling, is about visibility and the ability to focus on what the real priorities are. Not every problem is created equally. So we want to ensure that the solution is giving you a focus on those priorities that are most critical to the success of your organization. We have a few more webinars coming up. We're going to do the sales and operations planning aspect in a couple of weeks on July 26th. And so we hope you'll register for that, because it'll shed a bit more light on how we address the material planning dimension, how we use S&OP to build in that flexibility we're talking about. And it will also serve as a tee-up for how we think about production scheduling and optimizing on that front. As you know, we're going to be looking across a wide range here. You are somewhere on this spectrum of make to order to make to stock. And if you're genuinely focusing on becoming more agile and resilient, the tools and techniques you're going to apply to get to that stage are going to be different depending on the mix of your business. And so we want to ensure that we're illustrating how Intuiflow can help you, whether you're a purely make to order, whether you're purely make to stock, or somewhere in between those two ends of the spectrum, that we believe we've got capabilities that will really bring this agility and resilience to life for you. So with that, we're going to stop here and see if there were questions to be addressed. Kevin, can you help us out here?
Of course, yes, we did have a question come in from the audience, and it reads, do you have the ability to see impact on working capital, in parentheses, inventory turnover and on-hand cash, based on recommended buffers and assumed service levels?
Absolutely. Wally kind of showed you that in the part simulation. Whenever you're buffering, you know that there is a target inventory level. It's all of the red zone plus half the green. And we're able to track your progress against that, both at an item level, product category, by vendor, by any other dimension. So quite able to address those kind of requirements.
All right, next question. What is the logic behind the ML Red Zone feature?
Yeah, this is patented technology we're working with, so we're not going to be too clear here, but it is really running simulations and ensuring that it is addressing the most dense period in your demand. If you remember looking at that other graphic, and I'll bring it up here while we're talking on this page, the shape of those demand patterns has a big impact. How densely packed demand may be, how much amplitude you've got, and other factors like that. So it is recognizing the type of pattern that you have, and then finding the optimal settings for your red zone to address that variation. So it's really effective. I think the biggest piece of that is that it's visual. It helps the user gain more confidence because they can start to see why, like in the top case, we need more red zone because that item has a smaller green. It's not getting as much benefit. It's got a different kind of shape to its demand pattern, whereas the one at the bottom, big fat green zone. So we know that we're giving a lot of help to that just by the fact that we're buying so much at a given point in time. And I think the idea of this is to make it visual, make it something that's not a black box that people don't know how in the hell it's doing what it's doing. As long as they can see that it's going to achieve the desired result, that's what we're aiming to accomplish here. And as Wally mentioned, you do have the option of setting a minimum threshold of, like, we never want to be below 5 or 10% of our usage over the lead time, you know, kind of a true floor. It will plan the red zone factor accordingly. Other questions?
Okay. Oh, we just had another one come in. Is true demand defined as when material is consumed or what is ordered by customers each day?
If I'm looking at it from the finished goods stock buffer, it is the orders that are coming in, right? So in other words, we want to be able to satisfy every one of those orders on the day that they arrive. That to me is being truly agile, right? You've got the stock on hand to meet that order requirement. Your service levels are going to be extremely high, and that's the goal. From a historical data standpoint, oftentimes what data we're working with is the actual shipments. So if you were unable to hit the shipment targets or the orders that were coming in, your demand history may reflect an anomaly or a variance to what your actual order book was. So this is an implementation consideration. With the supply constraints companies are facing, some are considering shifting to what the order history was, not the actual shipments, because they're missing some of that demand and they don't want to short side their buffer by being too small because their actual shipments were below what the market was actually asking for. Very good question. Very much a design and implementation, or an implementation kind of question that should be considered.
All right, we got another question that came in from Eddie. Are there any tools that can help to determine the planning method for a particular part, i.e. buffered, non-buffered, min, max, etc.?
Yeah, great question. That's what this autopilot feature that I mentioned earlier is aimed to do. It will look at the items, the number of demand pulls, all the other attributes, and make a suggestion as to which ones would make sense for holding stock in. Some of those may not make sense, and so you'll have the ability with that tool to exclude certain items. Something that may be made as part of the production process, as part of the bill of material, is in your item master, but you never would hold stock in it. Items, you know, that never really need to be held in inventory. So you're going to have some flexibility in the way you use the autopilot to exclude items that would never qualify because of other business reasons, and then generate the proper recommendations based on its analysis. It's going to run simulations using DDMRP logic, high min max and low min max logic based on different service level thresholds you set, and come up with appropriate recommendations for that. So we're trying to really cover the waterfront for clients to ensure that we're giving them better guidance on how to maintain this so that they can keep that kind of that demographic refreshed on a recurring basis, say every week, every month, every quarter, whatever makes sense for their business.
Okay, next question is, how long does an Intuiflow implementation take?
Well, the world record was 4 days. I wouldn't suggest that's achievable on a consistent basis. That was a client we implemented in South Africa some years ago. We did the design workshop on Thursday and Friday, went home for the weekend, and then came back on Monday and Tuesday and went live on Tuesday night. But I would say probably in most cases, it's going to be a 3 to 4 month deployment model. It's going to depend on the activity within the client. It's not 3 to 4 months of dedicated 100%. Your users are fully engaged in the implementation. It's much, much lighter than that. But typically the longer tasks within that might be the integration to your ERP environment, some item master data cleanup, which inevitably needs some attention. And then the balance of the time is really user training, getting the buffers configured, assessing those initial estimates on what the target inventory levels would be versus the current levels, and kind of getting on a trajectory of how we're going to proceed once we go live.
Okay, another question we have is, we have long lead time items from overseas suppliers. How can we achieve shorter lead times?
Well, yeah, you could move your supply onshore. That might help a little bit, and some companies are doing that right now, but maybe that's not going to be the best answer from a cost standpoint. The way to do that is where you can, if you can buffer that, meaning you're going to carry stock of that offshore supplied item that has a 60-day lead time to ensure it's always available. You've now taken that 60 days out of the planning horizon. So in the example Wally did, we had a 25-day part. Items coming from Asia may be 60, 90 days, depending on their, how they're moved and things like that. And by buffering long lead time items, where you can make sense of that. Now, you may be heavily make to order and you don't have that option, but where you can do that, you cut down those lead times substantially. And we've seen clients take their planning horizon down from 50, 60 days down to single digits. Think about the flexibility that gives you from the standpoint of responding to the market. If my frozen schedule is only 8, 9 days long and I have changes coming in the market, well, now the likelihood is that I'm not going to have to change my frozen schedule, but I'm going to be able to respond within a few days to that new drop-in order that just appeared. So you really need to appreciate how much this idea of constant availability plays a role in creating that flexibility to the market that you're looking for. And that's where I think that the use of buffering where it's appropriate can have absolutely a game-changing environment. We've seen clients reduce their lead times in aggregate to the market while carrying less aggregate inventory, which is a little bit of a mind bender when you think about it, where if you had asked most supply chain planners, if you want to shorten your lead time, what are you going to do? And they're going to have to carry a ton of inventory. That's not always the case. In fact, if you really do it well and strategically, it's not going to be the case. You're going to be able to carry less inventory and be more responsive to the market.
Okay, staying on the topic of lead times, how are lead times compressed?
They're compressed by holding a buffer of stock. Other than changing the lead time by moving something onshore, if you want to do it from a material planning standpoint, by holding stock of that material with a DDMRP buffer, the logic in the software says that stock will always be available. Now, you want to manage that correctly. That's why this ML red zones is so important. You want to ensure that you're able to achieve that. But this decoupling logic, which is very unique and it's not found in traditional MRP environments, allows you to take that lead time and compress it down to a much lower level. So it's about proper application of DDMRP buffers within the context of your bill of material and your supply chain layers to get the right leverage of that.
Okay, and the last question we have is, how are items selected for buffering?
Again, that goes back to the autopilot. There's some cursory ways. We have a platform called Smart Buffer Profiler that's going to morph into autopilot. You're going to set some base parameters around what's the minimum number of usage or demand pulls in a year that we would want to buffer. When you get down into like that chart we had on the graphic there, when you get down to the lower end of that spectrum here, where you've got only a few demand pulses in a given year, the odds are carrying stock of that is not a good business decision, because you're going to hold a lot of inventory and working capital commitment for a demand that may come once, twice, 3 times a year, right? So there's some business judgment that applies there. If that's a Class A customer and you absolutely have to have that on hand, then you're going to hold inventory. So it's kind of hard to come up with a simple rule. That's why we use things like demand pulse thresholds as a way to filter out those candidates that are most likely going to be make to order or buy to order. The balance would then typically fall between a DDMRP buffer or a min-max setting. Min-max settings tend to be better for items that have very variable demand patterns. They're a more stable kind of environment. Sometimes the dynamic aspects of a DDMRP buffer are a bit counterproductive to what we're trying to do. And so having intelligent min-max settings kind of can work in those kind of troublesome areas. As you could see here, we've got some items in low min-max, which is kind of a lower service level threshold. Then you can see a fair bit of high min-max playing a role here as we get our number of demand pulses up during the course of the year. Okay. Any other questions?
That is all we have. Thank you, Eric.
Okay. Well, thanks so much, everyone, for your time and participation today. Hopefully you found this session valuable. As mentioned, we're going to cover the sales and operations planning dimension of creating agility and resilience on July 26th at 11 a.m. Eastern. So please register for that. Look forward to your participation there. Brittany and Wally, thanks for your help, and Kevin, yours as well. And we wish you all the best on your demand-driven journey. Thanks, everyone.